Assalamualaikum and good day all. It's me Faiza. So what are we going to learn today? So for this week, week 3, I will give a lecture on lab tests that normally will be conducted during the site investigation and interpretation of SI report. So the learning outcomes for chapter 1, week 3. At the end of this lecture, students should be able to discuss the laboratory tests that to be determined in the soil site investigation, because soil properties is very important for you to design later. And also students should be able to derive and interpret the information from the Borelog report. Okay, laboratory testing. So laboratory will be conducted based on site conditions and also based on the soil properties needed for the foundation design and analysis. So in your site investigation report, lab data also will be included in the report. Okay, basically we have 4 different properties of the soil. So for the first properties is the basic properties. So these basic properties is whatever that you can see with your naked eyes. So for example, the color of the soil, then you can smell the soil, then you can determine the moisture content. So just a simple test that you have to conduct. So description of the soil and the soil classification. Okay, for the second properties is the index properties, which is Atterberg limits. If you still remember Atterberg limit, which is liquid limit, plastic limit, plasticity index, okay, and shrinkage limit. Okay, so for cohesionless soil, you can for the soil classification, you can just simply stop from sieving. But for cohesion soil, you have to proceed with sedimentation tests like hydrometer, and then you have to proceed with liquid limit test, plastic limit test, and because you need to find out the plasticity index, because plasticity index is liquid limit minus plastic limit. So from the data, the value of liquid limit and plasticity index, you have to refer to the chart. So from the chart, you can classify the soil. Either the soil is for example MH, which is high plasticity, okay, high plasticity for silt. M is silt. Or you can find out that the soil is very low plasticity of clay. That is an example. Okay, because this classification of soil is important when you want to design later. Okay, because if you classify your soil correctly, so that would be the assumption for the soil characteristic when you want to design anything, any construction, or your when you want to calculate the bearing capacity based on the soil classification, because the cohesive soil and cohesionless soil, the characteristic is different. Okay, and then in terms of chemical properties, it's also important, because if the soil contains chemical such as sulfur or chloride, so there's a possibility of corrosion will occur. Okay, because sometimes we need to install piles, steel piles or concrete piles. So if there is a chemical content in the soil, so the chemical reaction will occur. Okay, and it's also will be dangerous, will defect the structure that will be to be built on the soil as well. Okay, the last and the most important properties is engineering properties. So the shear strength is the most important, because the shear strength properties, we have two, okay, shear strength properties, which is C, the cohesion, and also phi, internal friction of angle. Okay, and because based on the lab data, okay, that you find out, you conducted, okay, so when you get the C and phi value, okay, you need that value to relate, uh, or you need to use the value with the empirical equation, or either you have to calculate, let's say, the bearing capacity, which you will learn on the next chapter, chapter 2, or whatever design, slope design or returning wall, you need the shear strength properties, which is C and phi, and also the stiffness of the saw as well. Okay, whether the K value is less or high, the modulus of the saw, high or low, and the compressibility. So compressibility is what is we call that settlement. Okay, how much settlement that will be occur, okay, based on the consolidation properties. Okay, so we can predict, uh, based on the properties. And then the compaction with the CBR, so this is related with the pavement, and also the permeability. If you still remember, you have to conduct constant head or falling head based on different type of soil. So that's why it's very important, you have to classify the soil first. So make sure you classify the soil correctly, because what type of test, the following test, for example the permeability test that you have to conduct after you classify the soil, it depends on the whatever you classified before. So if cohesionless soil, so permeability test that suitable is falling head. Okay, for cohesionless soil, sorry, what I said that, okay, cohesionless soil suitable for constant head, cohesive soil for falling head. Okay, so those engineering properties are very very important for you for the next step for the analysis and design. Okay, this slide shows the soil classification based on British Standard BS. Okay, what is special about British Standard BS is that you can see here, the number is the magic number, what we call the magic number, 262626662. So always remember 262626662. So the soil is differentiate based on the particle size, so between 2 to 200, so it's coarse or gravel, okay, 600 here, and then between 2 to 0.06, okay, so this is the sand, and then we have silt and clay. Okay, so when you classify the soil, so this is the short form, the short form for GW means that gravel, well graded. Okay, G is gravel, P is the poorly graded. If you have sand, so SW, sand, well graded. Okay, so this is the fines content, okay, in the soil. Okay, so if still remember, this is sieving test. So you have this siever with different sizes of the mesh, the wire mesh. Okay, so you put it, this you put it in a descending order. Okay, the largest size on the top and the smallest size at the bottom, and the last one is the pen to retrieve the remaining or the salt particles that pass the final sieve. Okay, so these are the sieve. So make sure when you conduct the lab test, if you use BS, so make sure you use BS siever. Okay, if you use ASTM, so make sure you use ASTM siever. Okay, don't mix the procedure. Okay, so for sieve analysis, so we have actually dry and wet sieving. So both dry and wet sieving, we using this siever, the same siever, but the difference is that both when you sieve the sample, okay, actually when you sieve the sample, both method, this both method, dry and wet sieving, both method actually you sieve the sample is in a dry condition. Okay, dry condition. It dry, it doesn't mean that when dry sieving your sample is dry during your sieving test. Wet sieving means that your sample is wet when during your sieving. No, so wet sieving means that when you do the sieve test, the sample is also dry, but the difference that the sample is already soaked in what we mix sodium hexametaphosphate phosphate with the water. Okay, why we soak in that solution? Because we want to make sure that the salt particle disperse to just make sure they disperse, because if not the small particles, because you have to bear in your mind the fine particles, the fine salt particles is very fine. So when they and then they have a cohesion, so they will glue up together. Okay, they will glue up together. So when they glue up together, so they may make it a larger size as it's supposed to be. Okay, so that's why we need to disperse. So we soak the sample, the salt sample, in the solution that we have add water and sodium hexametaphosphate. Okay, and the rest is still the same, and the graph and so on. The difference only that the sample for wet sieving, the salt sample, you must soak with the solution of sodium hexametaphosphate to disperse the salt particles to the smallest, the accurate particle size. Okay, if not if you are not soak it and disperse this particle, you will get wrong salt classification, so it's very dangerous. Okay, so this is, if you still remember, or if you first time see this, so this is the hydrometer. This is the hydrometer bulb. This is hydrometer bulb. So hydrometer test, okay, hydrometer test is also under sedimentation analysis. Why it called sedimentation analysis? Because these salt particles, whatever salt, because this is the salt particles that you put in the this jar, cylinder jar, and you fill out with the water. Okay, so what happened? Okay, based on the Stokes law, okay, this is the velocity of the particle, the soil particle. So what happens that all the soil particles, okay, at first it will all will be together on the top here, okay. So by time, okay, by time, so this particle will settle down slowly. It depends on the diameter of the soil particle, so it will settle down. So it's like sedimentation, okay, if you still remember sedimentation. So until most of the soil particles settle down here, okay, settle down here. So that is what happening when you conduct hydrometer tests, okay. Okay, so this is you need to do when after you do the sieve test. So you have to plot this graph, okay. So when you plot this graph, okay, before you plot this graph, you have to do some calculation in the table, and then you have to plot this graph. So based on this graph, you will get the percentage of gravel, okay, gravel, sand, okay, sand, okay, how much sand, how much silt, so how much clay. So for this case, okay, for this case, it only contains gravel and sand, okay, gravel and sand. So this is well graded gravel. So right, so soil plasticity is about the Atterberg limit, okay. Atterberg limit, this is the founder. So Atterberg limit. So liquid limit, okay, liquid limit, either you can use a Casagrande test or cone penetrometer test, okay. So as you can see here, this is actually just to show you how the soil behavior. So when we say that the soil is in a liquid condition, means that it's like a pea soap, or maybe like what is that, pea soap, I can't remember anything else right now, okay. Pea soap, plastic condition, when the soil is in a plastic condition, it's behave like a peanut butter, okay, peanut butter. I think you are familiar with the peanut butter. Semi-solid, okay, semi-solid, it means that it's something like cheese, okay. When it's we said that the soil is in solid state means that it's behave like a hard candy or obstacle, okay, hard candy, okay. So I think you are already familiar with this one, okay. Okay, so to get the particle size, okay, you to classify the soil divided into two, either it's coarse grained or fine grained, okay. So for if you manage to get the coarse grain, so you don't have to do this test, you don't have to do this test, you only conduct this test, grain size and particle shape. And if fine grain, you have to conduct this, and then you also have to conduct this. Okay, this is how to get the liquid limit. This is Casagrande, okay. So the Casagrande is you get number of blows, okay, number of blows. So you plot and then get the best straight line at 25, okay, at 25, the number of blows 25. So touch to the best red line just now. So that is your liquid limit value. Okay. And then a plastic limit. Okay, plastic limit. You roll the sample, the soil sample, until it begins to crack and crumble. But the size of the diameter must be 3 mm. The size of diameter of this sample, soil sample that begin crack and crumble, the size must be 3 mm. So that is then you check the moisture content of this soil sample. Okay, so that is your plastic limit value. Okay, just now when I said that you have to conduct the sieving test, so you have to refer to British standard. Okay, so this is 1981, but we have superseded BS 1999, BS 590. 1999 already superseded the previous version, so this is the latest. Okay, so first thing, okay, you have to check. The first thing when after you do the sieving test, you must make sure whether the soil is coarse or fine. Okay, coarse means that either it is gravel or sand. So coarse means that less than 35% of the material is finer than 0.06 millimeter. Okay, so if more than 35%, if more than 35% passing 0.03, so means that the soil is fine. Okay, the soil is fine. Okay, if less than 35% passing 0.06 mm, so consider coarse soil. If more than 35% passing 0.06 millimeter, so that is fine soil. Okay, so fine soil either clay or silt. Clay or silt. Okay, clay or silt. So you have to proceed with the liquid limit test. Okay, liquid limit test. Alright. Okay, after you have managed to get, let's say percentage. Okay, percentage of the sand, percentage of the gravel, and if you have clay, so you have the percentage of the clay. How much is the percentage of the clay? So you have to refer to this chart or table from BS 590 1999. Okay, so from this you will come up with the soil name. So very gravelly sand or whatsoever. Okay, slightly sandy. Okay, slightly sandy. If the sand is the majority, means that more than 30. The major means that if the soil is only sand, contents of sand and gravel, so you have to check which one has the highest percentage. Okay, so then this is if sand or gravel, and sand and gravel only, means that you refer this table if there is no fine, means that there is no silt and clay, so you refer to this table. If after you plot the graph just now that I show you just now, if from the graph it contains of sand, gravel, with clay or with silt, so you have to refer this. Okay, you have to refer this table. Okay, because based on the percentage, so you will describe the soil, and you will come up with the name of the soil. Okay, so this is our USCS. Okay, means that you use a procedure ASTM, not BS. So if USCS, is just follow the arrow. If the liquid limit less than 50, so follow the arrow whether it's inorganic or organic soil. So if inorganic, you go to inorganic, and then check the PI, the plasticity index value. So how much? So if more than 7, so go here. So then what is the symbols? The CL. C is represent clay, M represent silt. Okay, and finally you will get the name of the soil. Okay, so this is also the same. This is gravel and sand. Okay, this is for organic soil. Okay, here you can see the difference between BS and USCS. The gravel size. Okay, the gravel size for BS is between 2 to 60 mm. Okay, 2 mm until 60 mm for BS. Okay, the gravel size. But for USCS, it's 4.76 to 76.2 mm. So the size is different. So you must be careful whether you use BS or USCS. Okay, so whatever you do, you must jot down, written in the report which procedures that you use. Okay, so this is the plasticity chart. This is based on the BS. Okay, so this is the plasticity index value, whatever you have here, and then you have liquid limit percent. So let's say if your liquid limit is 60 and your plasticity index is 20, so liquid limit 60, here is 60, and plasticity index 20, so it's somewhere here. So means that your soil is MH. M is the silt, H is the high plasticity. Okay, so that is how you classify the soil based on this plasticity chart. So this is ASTM. So ASTM and BS is always different. Okay? Just a little bit different. Same with cone penetrometer test. So make sure the cone that you use, the apex angle of the cone is different between the cone for ASTM and also cone for BS. Different. So you must make sure that you use that. You check the apex angle of the cone before you conduct the test.